Hello, ninth graders. So we are today we're going to talk about graphs and what we do with graphs, how we make graphs, how we interpret graphs. These are all things that you. This is not the first time you've ever graphed, so hopefully these are all things that are pretty much refreshers, but just kind of thinking about it in a more accelerated way. So I've got two things that I would like to, equations that I would like for us to graph together on this piece of paper. And we, for the most part, know how these graphs behave. We know that because this has the highest exponent of a 2, that this is a quadratic. So we know that's going to look like a parabola. And we know a little bit about the vertex form of the quadratic in order to also make a few assumptions before we start graphing it. If you remember, we might have talked briefly in class about something called a parent function. Parent as in your mom and dad. It's a parent function. Um, and the parent function for quadratics, for all quadratics, is the most basic quadratic you can think of, which is just x squared. That is the parent function for all quadratics. And what it means is that any other quadratic that you see is some sort of transformation of the parent function. This is some sort of transformation from your original parent function. When we put it into vertex form, we can look at how the original parent function was transformed such that we now know where the new vertex is. And it follows your basic transformation rules, where if something is happening outside of the function, this is going to indicate something to us about how it's going to change vertically, right? Since it's not happening inside parentheses that are being squared, this -4 means that our vertex is going to move down 4. It's going to move exactly the way that we think it's going to. The fact that we're multiplying by 2 means that it's going to be really, really steep, and it's going to open up because it's positive. So there's always a few things that we can think of if we try and compare a graph to its parent function, to try and think of like, okay, this is how we think the graph is going to behave. Now, we don't always know how the parent function looks, and we can always have a good idea from what's going to happen by looking at the parent function and the transformation. But always, it's a good idea to just make a table of values and graph from your table of values. This gives us a good idea of like maybe what we should expect by saying, hey, I know I'm going to be going down 4. I know it's going to be really steep, but let's just try and plug in some points here. So I've got my x and y values. It's always good to have 0 represented as an x value. We almost always want to know what's going on when x is equal to 0. And then we should have a few positive numbers and we should have a few negative numbers. I'm going to be smart about this, and I'm going to say, well, hey, I know I'm going to be multiplying. I'm going to be squaring this number, this x value, and then I'm going to be multiplying it by 2, which means I'm going to be dealing with some pretty large y values. So I might go 1, 2, and -1, -2, just because I'm trying to keep my x values small, so I'm not going crazy because I only have so much space. Okay, so if I plug in -2 squared is 4, times 2 is 8, -4 is back to 4. -1 squared is 1, times 2 is 2, -4 is -2. This would be -4, and then this would be -2, and then 4. Which is pretty cool. So I'm going to go ahead and start plotting these points. I'm symmetric across that y-axis. My vertex is on the y-axis. So I'm going to go ahead and put that there. And I go all the way down to -4 and then all the way up to +4, which means I also want my x-axis to be fairly centralized. Kind of hard to see because of the glare with the pencil marks, but I went ahead and put in my axes. We'll label them because we're good math students. And we'll just go ahead and plot these points. -2, 4, -1, -2, 0, -4, and so on. So we got ahead and plotted these points. We connect them by making them as beautifully curved as we possibly can, or your best interpretation of a beautiful curve. Make sure to put arrows at the end, and you are now done. So there's a few things that we can always think about when we're trying to think about how to graph a function. One, we should always try and reference it back to the parent function. And we know that there will be a few things, a few patterns that stay the same. If there are things happening outside of the parent function, they're happening in a vertical way. and they're happening exactly the way you think they're going to happen. -4 means that we're going down 4 here. +1 is happening outside of the parent function. F of x equals the absolute value of x. So parent function right here, +1 means that we're going to be moving up 1. So that pattern still stays the same for all of our transformations. So that's the first thing you should always be thinking about when you're graphing is, okay, what is the parent function? What does the parent function look like? And then how am I transforming it with this particular function? And then from there, a good place to move next is to make a table of values. It's always good to have 0 represented. And then in this case, I might do like -2, -4, and then, oh, whoops, 2, 4. Just because I'm changing about which values, but I have some positive, some negative, and a 0 represented. So those are all some pretty good rules of when I'm plotting using a table that I should include 0, some positives, and some negatives. Okay, at 0, I plug in 0 for here, and I get 1 as my value. -2, -0, 1, 2 would then be 3, and then 5, and then -1. No, that's the same thing, 3, and then 5. So then 2 would be up here at 3. -2 would also be up here at 3. -4 would be up at 5. Same with +4. So we do notice that this tends to have similar patterns of our parabola, how there's this idea of a vertex, how we have end behaviors that behave the same way. The end behavior of the graph is that both ends are shooting upwards. But this is a fundamentally different problem. It's an absolute value problem, and absolute values are not curves. They are actually lines. It's because the idea of this equation, this function without the absolute value would be a linear function. X plus 1 is linear, not with this squared piece. The squared piece makes it a quadratic. But making it an absolute value then still keeps that linear behavior. So that's another thing to keep in mind, that yes, we can always make a table of values and graph it, but you need to also understand the fundamental reasons of why, or the fundamental behaviors and visual cues of parent functions in order to know how to connect the dots. Okay.